In this lesson, we're going to continue our discussion from last time about mole ratios, and we're going to combine how to solve more complex problems using this three-step process that we see. And so the first step, as you can see, is convert to moles. Now, if you've forgotten how to convert to moles, then you might want to watch a previous video about that. That's linked on my YouTube channel. After you convert to moles, we're going to carry out the mole ratio that we learned in our last lecture. We'll do several examples of that. And then the last thing that you do is you convert to the final unit, which sometimes may be grams or liters of gas at STP or molecules or something else. Well, we're going to learn this three-step process by practicing it. So here we have an example. We have a problem, and we have a balanced equation once again where 4 moles of aluminum, that's what the 4Al means, plus 3 moles of oxygen gas produce 2 moles of aluminum oxide. And so the question says, how many moles of aluminum oxide can be produced from 75.0 liters of oxygen gas at STP? Well, when we have this type of problem, we're going to start with what's given to us. So I'm going to write 75 liters of O2, and that's what we're starting with. And the question is asking how many moles of aluminum oxide. So that means way down here at the end, I'm going to have equals moles of aluminum oxide, Al2O3. And we're going to solve using our three-step process. Now the first step that we said was convert to moles. And so I'm going to have a conversion factor here, and we're going to convert to moles. Now if you might remember from a previous lecture about mole conversions, to convert to moles, well, we have to put moles on top of our conversion factor. And the unit that goes on the bottom is the unit that we're converting from, which in this case is liters. So liters goes on the bottom. Now, we know from the chapter about moles and mole conversions that 1 mole is equal to 22.4 liters of gas at STP. And we can see we have a gas at STP here. Liters will cancel, top and bottom. And so if we were to stop here, we'd be in the units of moles of oxygen. But we don't want to be in moles of oxygen. We want to be in moles of aluminum oxide. So this is where step 2 comes in, and that's the mole ratio. So that requires another conversion factor here. And this time, we're going to use chemicals, essentially, these substances, instead of units. And so I see oxygen is what we're starting with. So I'm going to put oxygen on the bottom of my conversion factor. And since I'm converting to aluminum oxide, Al2O3, that's going to go on the top. So this is a little bit different than other conversion factors we've done. And we're going to use coefficients of the balanced equation in our conversion factor. So Al2O3, if we look up at the balanced equation, has a 2 in front of it. So I'm going to put a 2 in the mole ratio for aluminum oxide. And next to O2, there's a 3 right there. So I'm going to put a 3. This is a 2 to 3 ratio. So now I can cancel O2, top and bottom, and I'm trying to be in moles of aluminum oxide, and I'm in moles of aluminum oxide. So all I have to do now is multiply and divide. So in my calculator, I take 75.0 times 2 divided by 22.4 divided by 3, and the answer I get is about 2.23. So the answer is 2.23 moles of aluminum oxide. Let's try another example. We're going to use the same balanced equation this time, except we're going to change the question. This time it says, how many grams of aluminum oxide can be produced when 46.0 grams of aluminum is reacted with excess oxygen? So once again, I'm going to start with what's given to me, which is 46.0 grams of Al, aluminum. And the goal is to convert to grams of aluminum oxide. So way down here at the end, I'm going to have grams of Al2O3. And so we're going to go through our three-step process. The first step is to convert to moles, just like it was last time. So we have a conversion factor. Grams need to go on the bottom, and moles go on top. Now, how do we determine the number of grams in a mole of something? Well, you might remember from our chapter on mole conversions, we have to look at the periodic table. So we look at the periodic table square for aluminum, and we look at the atomic mass, and it's right there. It's 26.982. And so I'm going to round that to the nearest tenths place and say that 1 mole of aluminum is the same as about 27.0 grams. That's close enough. So I can cancel grams, top and bottom. We're now in moles of aluminum. So the second step is the mole ratio. So I have a conversion factor for that. And can you tell what chemicals or what substances will go in the mole ratio? I hope you realize that Al, aluminum, goes on the bottom, since that's what we're starting with. And we're converting to Al2O3, aluminum oxide, so that goes on top. And the numbers that go into this conversion factor will be coming straight out of the balanced equation. So 2 next to aluminum oxide, and this time it's a 4 next to aluminum. So this is a 2 to 4 ratio. Aluminum cancels top and bottom. We're in moles of aluminum oxide. We want to be in grams of aluminum oxide. So that the third step is to convert to that final unit, which is grams. And so that requires one more conversion factor. So this time, looks like moles will have to go on the bottom, since that's the unit that we're trying to get rid of. And we're converting to grams, so grams goes on top. And once again, how many grams are in a mole of aluminum oxide? Well, we're going to have to go back to the periodic table. Here's the periodic table square for oxygen. So we're going to have to add up 2 aluminums and 3 oxygens. So can you figure out how many grams are in a mole of that? Well, if we have 2 aluminums and it's 27.0 apiece, times 2, that's about 54.0. And then if each oxygen is about 16.0, and we have 3 of those, that's about 48.0. So if you add those up, the total mass of a mole of this substance is about 102 moles, or rather 102 grams per mole. So that's why we have 102 grams per mole of this. So I'm going to cancel moles. And of course, this is a skill that we learned earlier in the course. So this time we have to go back to our calculator now. We take 46 times 2 times 102 divided by 27 divided by 4. And so the answer this time is about 86.9. So the answer is about 86.9 grams of aluminum oxide. So this time we had to do all 3 steps in our 3-step process. Let's do one more example. This time we have a different balanced equation. We have 1 mole of nitrogen gas plus 3 moles of hydrogen gas yield 2 moles of NH3, which is ammonia gas. And here's the question. How many grams of ammonia, NH3, can be produced from 8.82 moles of hydrogen? So we're going to go through our same process. We're starting with 8.82 moles of hydrogen. And the question says, how many grams of NH3? So that means way down here at the end, we're going to convert to grams of NH3. Now the first step, as you recall, is convert to moles. Now, do we need to do that? Well, you can see the question is already in moles, and so we don't have to convert to moles. It's already in moles. So we can go on to step 2. Step 2 is the mole ratio. So what units, or rather what substances, go in the mole ratio? Well, hopefully you see that H2 needs to go on the bottom, since that's what we're starting with. And NH3, ammonia, needs to go on the top. And the numbers that go into this mole ratio, well, you see that there's a 2 next to ammonia, so 2 there, and the next to H2 is a 3. So this is a 2 to 3 ratio. H2 cancels top and bottom. Next, we have to convert to our final unit, step 3. Because we're in moles of ammonia, we want to be in grams of ammonia. So I want to do that third step, and it looks like moles need to go on the bottom, and grams need to go on the top. And how many grams are in 1 mole of ammonia? Well, we have to refer to the periodic table, and there are the periodic table squares for nitrogen and hydrogen. So can you determine how many grams are in a mole of NH3? Well, every N is 14, and we have 1 of those. Every hydrogen is about 1, and we have 3 of those. So 14 plus 1 plus 1 plus 1 would be about 17 grams, 17.0 grams. So we're going to cancel moles top and bottom. And now we just have some arithmetic to do. 8.82 times 2 times 17.0 divided by 3 give us our answer, which is very close to 100, about 100 grams of ammonia. So hopefully after watching this video, you're familiar with this 3-step process, which is called stoichiometry. This is being able to use a balanced chemical equation to determine how much of a reactant or a product can be expected from one of the other reactants or products.